Good morning, everybody. Welcome to our second part of the notes, which is going to be over pyramids and cones, some more volume. Our learning targets are, I can find the volume of cones and pyramids, and I can solve real-world problems involving volume. Some vocab review. A pyramid is going to be just like these ones down here, where it will have just one vertex, and it will have it could have any kind of base, triangle, rectangle, square. And the height of the pyramid is from the vertex all the way down to the center of your shape, whereas a cone is very similar, except for its base is always a circle. Big B, that just means the area of the base, and height, we know what height is. So, trying to find height on different kinds of shapes, height is always just the highest point down to the lowest point. So that would be height here. The height for this one is our highest point, the vertex, all the way down, straight vertically down. Same thing here. This would be our height, or this would be our height, and this would be our height, or this would be our height. Again, it is the furthest distance you can travel vertically up and down while going straight vertical, not diagonal at all. The height on these ones is this outer rim. You can see that this is the highest, highest vertical points here. Really, any of these and all of these would be the height. The height for a cylinder is the outer edge right here. So this one's laying on its side, but this is still the height. And this right here would be the height for this one as well. Over here, the height's already labeled, but again, it's that vertex straight on down. So, for pyramid and cones, I've got your formulas already written here. For a pyramid, it is volume equals 1/3 big B times h. And for a cone, it's 1/3 pi r squared times height. Now, one thing that you might notice is that this formula for a cone is incredibly similar to a cylinder. A cylinder is volume equals pi r squared times height, and a cone is 1/3 pi r squared times height. So the only difference between these two formulas is the fact that you are taking 1/3 of it with the cone. Same thing with a pyramid. It is 1/3 base times height. And if you look at the formula for a general prism, it is base times height. So again, a pyramid is the same thing as a regular prism. It's just you need to take only 1/3 of it, because it is just, quite frankly, 1/3 the size. So let's go ahead and put it into practice on this one. We have this pyramid here. It gives us a height of 10. It is 10 wide, 10 long here. The big B is going to be the area of the base, and this is going to be a rectangle. So big B is going to be length times width. And so we'll do volume equals 1/3 times our length times width, which is 10 times 13, times the height of 10. And so if we go ahead and do this, 10 times 13 is 130. Timesing by 1/3 is the same thing as dividing by 3, if you did not know that. And times that by 10, which this is going to get us V equals 433.3 repeating. This would be our volume. Plus, we need units, of course, inches cubed. Over to the cone. Again, we can just recognize here we've already got our radius and we've already got our heights, so 2 and 8, which means we're ready just to plug stuff right on back in. So volume equals 1/3 times pi times the radius squared times the height. And so if we go ahead and do this, 2 squared is 4. 4 times 8 is 32. Times by 1/3 is the same thing as dividing by 3. So volume equals 10.6 repeating pi inches squared. Okay. And if you wanted to write this in the estimated form, you would take your 10.6 repeating, multiply that by 3.14, and that would get you 33.493 repeating with just the 3 repeating inches squared. Alrighty. Moving forward, we have a composite figure here that is made up of 3 different shapes. We have a cone on top, a cone on bottom, and a cylinder in the middle. I want you guys to go ahead and pause this video and try to find the volume of all 3 shapes and find the total volume. Okay, so hopefully you noticed for the cone on top that the width of the cylinder is going to be the diameter of the cone. So the diameter is 6, which means the diameter down here is also 6. And hopefully you also recognize the cone on top is the same exact size as the cone on bottom. So if you find the cone on top, we've automatically found the cone on bottom as well. So we're going to go ahead and name it. I already told you, it's a cone. And the formula is volume equals 1/3 pi r squared times height. The one in the middle is a cylinder, which is 1/3. Sorry, I should probably put my V equals here. V equals not 1/3, sorry. Just pi r squared times height. So let's go ahead and do this problem. V equals, and it does say keep in terms of pi until the very last step, so we are going to keep the pi symbol there until the very end. 1/3 times pi times our r squared, which is 3 squared times a height of 4. So the volume for this one is going to be 9 times 4 divided by 3. So this one's going to be 12 pi. This one here should be very similar results. So pi times r squared, the radius again is going to be 3 here. The height this time is 8 though. So 3 squared is 9, 9 times 8 is 72. So this is going to be 72 pi. And the last one, like we already said, is the same exact as the top. So we already know the volume for this one is 12 pi as well. So for the total volume, it's going to be 12 pi plus 72 pi plus 12 pi again, which 12 plus 12 is 24, plus 72 is going to get us 96 pi. And it doesn't, oh, it looks like this is feet, I believe. No, those are arrows. So it does not give us any units, so we'll just call this 96 pi, or 96 times 3.14 is 301.44. So these would be the 2 acceptable answers. And that is going to do it for our notes today. If you guys have any questions, please feel free to let me know. And I hope you guys have a great day.